So that sphere is made of 120 small pieces. Here's an individual piece, this little yellow piece. All the pieces are the same shape. The only difference is that half of them have a right-handed orientation and half of them have a left-handed orientation. So you see here the red and blue triangle, they pair up. The blue one I would consider the right half and the red one the left half. But these are the same size triangle, it's just one has been reflected or flipped. They're symmetric to one another. That sphere is made up of 120 of these pieces that go together, and that is the largest number of congruent pieces that can go together and tile the surface of a sphere. Again, congruent if you allow symmetry, reflective symmetry. So how are these pieces held together? Well, I'm using magnets to hold them together. You can see maybe on the green piece here, there are magnets embedded on each of the sides. 3 sides on the triangle, of course, on the triangular prism, and in each one these are embedded. Now these are actually inside the hollow triangle. I do that when they're 3D printed. I will show that in the next video. The next intermission video shows how I actually get the magnets in there. Whenever you deal with a toy or a puzzle that is going to use magnets, I actually prefer mechanical puzzles if you can make something completely mechanical without magnets, but magnets can be useful, but you have to be very careful because usually you use very strong magnets in puzzles or toys, and you have to make sure that they're not going to pop out because you don't want any chance of accidentally swallowing one, or actually swallowing 2 of them is the big problem, because then they can get in your intestines and all this stuff, and it's, while it sounds silly, it is not a silly thing at all. So the magnets you want to make sure do not come loose. So these are not glued into the side of these pieces, or this plastic piece has not been glued together with magnets inside. This was actually 3D printed layer by layer, and as it printed upward, I inserted the magnets, and then the 3D printer printed plastic on top of it. So it is completely encased. The only way you could get these magnets out were if you literally took a hammer to this piece. You could break it open, or you could melt it if you really wanted to get the magnets, but at that point, you know, then you're just really wanting to hold the magnets. But these aren't going to just pop out. There's no glue to come loose or anything. These are more or less welded or fused inside of these pieces. How that is exactly done, again, I will show in a later video. But these are kind of a pain to make because I have to make 120 of these pieces of various colors. But you see that they do click together. And each piece has 3 magnets, and I also have to make sure that the polarity of the magnets, a magnet of course has a north pole and a south pole, I have to make sure that I insert them into the pieces correctly as it's being 3D printed, so that opposite pieces, left and right pieces, will in fact snap together in any of their sides. If I were to accidentally flip one of the magnets as I inserted it, then the appropriate pieces would not click together. They would repel one another, which would make a pretty crappy toy. So anyway, I will show more of this in later video, but that's what these individual pieces look like, and there are 120 of them.